Hello everybody, welcome back to another integration techniques video. In this video, we are going to learn about use substitution method, which is very popular method. The goal is here just simplify the complex integral into some integrals, which is we can easily integrate with basic integration techniques, which we have learned in first video. If you haven't watched this video yet, you can watch somewhere of this video, because if you don't know these techniques, this tutorial will be hard for you. So let's start with first example. Let's say we have integral this dx is equal to 5x plus 8 dx. And we have already have dx, so we don't have to learn about write about this. Okay, so how we can integral this complex integral? So we use substitution method. So if we substitute this expression 5x plus 8 IU, so we find derivative of both sides. We just find derivative respect to x. So you know that like in this type of expression, we have only integral is going to be 5, and this is equal to du divided by dx. From here, we will find that dx is equal to 1 over 5 du. So our integral will be converted as something like this. Well, instead of dx, we will write 1 over 5 du. So that will be integral 1 over 5 du. That will be du divided by under the root of u. So we know that we can write out of the integral this constant, that will 1 over 5, 1 over under the square root of u, du. So we can just simply integrate this 1 over under the square root of u, du. So we can apply power rule, which is we can write it as a 1 over, so it will be u over negative 1 over 2 du. So we can apply power rule, which is integrate of un is equal to un plus 1 divided by n plus 1, which is here our n is negative 1 over 2, which makes the integral as a, so it is 1 over 2 divided by 1 over 2. So that will be 2 under the square root of u. So instead of this, we will write, so we will integrate it. We will have 1 over 5 times 2 under the square root of u, and 2 under the square root of u divided by 5. So we never forget to write what you substitute. We substitute u is 5x plus 8. So we write 2 under the square root of 5x plus 8 divided by 5. And we will have plus c. So that's how we integrate the complex integral into a simpler form. So let's look at the other example. This part. So second integral, let's write something like this. Integral 2x divided by the root of 3x squared plus 1 dx. So in where, let's stop this video and think about what we can substitute. The goal is here, we when we substitute u, after finding derivative, we will simplify it. Like something we will, instead of dx and these things, it make something simpler, and we will have only du. So like something with dx, we can simplify when write this. Like if I take u is equal to x squared plus 1, and when we find like derivative of both sides, du divided by dx will be 2x. So from here, dx 2x is equal to du. So the dx will be du divided by 2x. So when we write this again, so that will be, instead of dx, I will write 2x. Like instead of dx, I will write du divided by dx, 2x, sorry. So when we write this, we will have something like this, du divided by under the square of cube. So we just write x squared plus 1, we substitute by u, so we will have u. Then we will write this 1 over the u1 du, and that's equal to u over negative 1 over 3 du. Again, we apply power rule. Which is un is equal to un plus 1, n plus 1. So our n is here negative 1 over 3, which will be 2 divided by 3 divided by 2 divided by 3, which is 3u 2, 3 divided by 2. But we never forget to write that over 3. U is x squared plus 1, which is x squared plus 1 is cube 2 divided by 2, which is our plus c. So you see, when we write dx is if du divided by dx, we got, like, we simplify. They take each other. Let's just look another example. Let's again write to this short example. Let's write something like this: 9x squared divided by the square root of 1 minus x cubed dx. Again, stop this video, think about which you can substitute, and when you find derivative of it, you will get something simpler. And when you should, when you write instead of dx, you will take out something and convert to simpler integral. In this case, we can write u is equal to 1 minus x cubed. When we find derivative of both sides, we will du divided by dx is equal to negative 3x squared. So du is equal to dx times negative 3x squared. So dx is equal to du divided by negative 3x squared. And I wrote it again, 9x squared. We let us go to u times, instead of dx, I wrote du divided by negative 3x squared. Then they will take each other. I will have negative 3 here. So it will convert it as negative 3 du divided by under the root of u. So we can take out this negative 3 out of the integral. So it will be 1 over u divided by du. So again, well, under the root of u du, we can write it as a u over negative 1 over 2 du. So again, we will apply power rule. That's h is this is equal to underscore u, and here n is negative 1 over 2, which makes us u over 1 over 2 divided by 1 over 2, which is 2 u 1 over 2, which makes 2 under the square root of u. So we substitute u as a 1 minus x cubed, which is 2 times under square root of 1 over x cubed. And we write this, so we just write negative 3 times 2 under square root of 1 over x cubed, which makes negative 6 under the 1 minus x cubed. That's our answer for C, of course. Let's look another example.